In our final section of chapter 3, we're going to talk about the factor theorem. We very briefly discussed that in our last video. So the factor theorem states that if x minus a is a factor of the polynomial in x, p of x, and if and only if p of a is equal to 0, meaning, so if I have that divisor, so like x minus 3, and I put in this 3 and substitute it into my original polynomial, if it shows that there's no remainder, then it is in fact a factor. So how can we use this? Determine which of the following binomials are factors of the polynomial. So we have a polynomial right here and some potential factors. So what I'm going to do is I'm going to substitute our values into x and see which ones have no remainder left over. So this one's going to be a 1 because again the original form is x minus a. So p of 1 equals 1 cubed plus 2 times 1 squared minus 5 times 1 minus 6. So then quickly using a calculator, we'll find out that it's equal to negative 8. So no, that's a remainder, doesn't work. Okay, let's go on to the next one. So here, this is actually a minus negative 1, so therefore we're going to substitute in p of negative 1 and see what happens. So we get negative 1 cubed plus 2 times negative 1 squared, does not look like a 3, minus 5 times negative 1 minus 6. And when we evaluate that, we get 1. So again, we have a remainder, so therefore x plus 1 is not a factor. Okay, let's go look at our last one. So here we're going to put in 2. So p of 2 is equal to 2 cubed plus 2 times 2 squared minus 5 times 2 minus 6. And we find that that's equal to 0. So yes, this is a factor. Is a factor. So therefore, our only one is x minus 2 is a factor. Now this has a lot more uses than just, oh, is this a factor? Is this not a factor? When it says fully factor, we can't use PSA. We can't use difference of squares. We can't use perfect square. So we have to find some other method. And one of those methods can actually be doing a division. And so if that division is possible, then we found a factor which might make this to a degree, so for instance a quadratic, where we can actually factor it. And now how we determine what that division actually is all based on the constant, because we need that constant at the very end to be equal to 0. So we need to look at what are the factors of 3. So we have two possible scenarios. We have negative 3 times negative 1, or we also have 3 times 1. So we have 4 numbers that we have to input into our original equation and determine which one actually equals 0. So we have a remainder. Now I'm going to let you mess around with that. I know that it's actually going to be this negative 1 right here, and I'll prove it. So p of negative 1, I'll substitute that into this. So we get p of negative 1 cubed minus 5 negative 1 squared minus 4 times negative 1 plus 3. And all of that is equal to 0. So therefore, I know that x plus 1 is a factor. Now you're probably thinking, well, wait, we substituted negative 1. But remember, this is x minus negative 1, which becomes plus 1. So now we can use this factor to actually do a division and figure out what our other quadratic is. So I'm going to do synthetic division. So this does go cubed, squared, 1 constant. So then I can write out my coefficients of 2, negative 5, negative 4, and 3. And then make my little chart. So I'm going to have a plus 1 here, and then a minus, and a times. And now that I've got my chart, I can start doing this. So I'm going to drop down the 2. And then 1 times 2 is 2. Negative 5 minus 2 is negative 7. 1 times negative 7 is negative 7. And then negative 4 minus negative 7, well, it's actually like adding. So we get positive 3. And then 1 times 3 is 3. And 3 minus 3 is 0. So perfect. We've done it correctly because I have a remainder of 0. So therefore, my quotient is 2x squared minus 7x plus 3. Now the question is, can I factor that anymore? So it's a quadratic, so possibly. I'm going to do PSA 2 on it. So I'm looking for a product of 6, a sum of negative 7. And my answer becomes negative 6 and negative 1 then. So I'm going to do that split. So 2x squared minus 6x minus x plus 3. And I'm looking for a GCF in these first two terms. Well, it's 2x. And then in my second term, now this is a minus 1. I need to make that a positive. So I'm going to divide by negative 1. So one of my factors will be this 2x minus 1. And the other factor will be, well, 2x squared divided by 2x is x. And then negative 6 divided by 2 is negative 3. And x divided by x is 1. So there we go. So now I've fully factored this quadratic, but I need to put what my final answer is. So therefore, we have our original factor, which is x plus 1 times 2x minus 1 times x minus 3 is equal to 2x cubed minus 5x squared minus 4x plus 3. I'm going to leave the second polynomial for you to factor on your own on this page. And let's take a look at this third one. So again, fully factored, x cubed minus 8. And same thing, there is possibly a way because it's a cube, but we haven't learned anything about that yet. So I'm going to look at this minus 8. What are some factors of negative 8? Well, we could go 2 times negative 4. We could go negative 2 times positive 4. We could go 8 times negative 1, negative 8 times positive 1. And you'd have to go and input all these values into here. And again, I'll let you do that on your own. I know that 2 works. Another way to check kind of which one could work is you could go into your calculator, graph this, and then actually see, is there an x-intercept that is actually a nice one? And that will match up with one of your values. So again, I'll prove to you though that p of 2, so 2 cubed, minus 8, well, yep, that's equal to 0. Okay, so then we know that one of our factors is x minus 2. So that means we're going to take this polynomial and actually do synthetic division on it. Now again, we have cubed, we don't have squared. So I'm going to have, this is actually x cubed plus 0x squared plus 0x minus 8. And doing synthetic division on that then, I'm going to take my coefficients. So I've got 1, 0, 0, negative 8. And then I can make my little chart. So we're going to divide by negative 2. And we got a minus, a multiplication. Okay, we're ready to go. So we're going to drop down this 1. And then negative 2 times 1 is negative 2. 0 minus negative 2 is positive 2. Negative 2 times 2 is negative 4. 0 minus negative 4 is positive 4. Negative 2 times 4 is negative 8. And then negative 8 minus negative 8 is 0. Awesome. We have a remainder of 0. We've done it correctly. Now just be careful with our coefficients. We have an x cubed to start. So this is going to become an x squared then. So we have 1x squared plus 2x plus 4. Now we should see if we can factor that. So we're going to use PSA. So the product we're looking for is 4. We're looking for a sum of 2. And actually, that's not possible. So therefore, we cannot factor x squared plus 2x plus 4. So therefore, my fully factored form is x minus 2 times x squared plus 2x plus 4. Now I'm going to let you do this last one on your own. This is a nicer number, only minus 6.